in the top ones and negative signs in the bottom ones. Okay? So we're going to use chips to model this problem. Okay? You have 8 positive chips and 3 negative chips. Okay? What happens if I ask you to take -1 and add 1? What do we get? 0. -1 plus 1 is 0. Okay? So, what is happening with 1 positive chip and 1 negative chip?
We're canceling each other out.
Okay, so what I want you to do is put your fingers on 1 positive, 1 negative, and move them over. 1 positive, 1 negative, move them over. 1 positive, 1 negative, move it over. Everybody do that. Okay. On your paper, let's do this. We cancel them out. A negative and a positive cancel each other out. So, how many chips are left? 5. And what kind of chips are they? Positive. They're a positive 5. Okay. So I just took one problem and I modeled it for you 2 different ways. Okay. Do you have to use either of these strategies? No. But you can. Okay. So I am going to have you work with the chips for a couple problems just to kind of get used to what our brain needs to be thinking about. Okay. So take those positive chips. Count out 5 positive chips. Count out 2 positive chips. Okay. Do we have anything canceling out? No, we don't. We have 5 positive chips. We have 2 positive chips. There's no negatives canceling out. So they just combine to be 7 positive chips. Okay. Take your negative chips. We have 2 negatives added to 1 negative. How many negatives do we have? 3. Okay. Let's look up here at the number line. I'm at 5. I move forward 2. 5 plus 2 is 7. Letter B. I'm at -2. How do I move forward -1?
You gotta move back.
Okay, forward -1. I'm at -3. There's the number line. Okay, with or without the chips, you and your elbow partner decide on the right answers for C and D. Answer C and D for me, please.
Well, I think
Yeah. Do you have a loaner computer?
Yeah.
Okay, Miss Boyke needs you to bring it, and I think she has your real computer, so I'm gonna send you one. Okay? All right, Trayson, what did you get for C? This one right here? We're on example 1.
Oh, yeah, the one. -17.
-17. Okay. Anybody disagree? Okay. Ariana, 21. Anybody disagree? Okay. Tell me what is true about all of the problems in example 1. What is true about all 4 problems we did in example 1?
These equations, they all use the same sign.
Ah, so both of these were positive, or both of them were negative. Both of these were negative. Both of these. Okay, Jackson.
They're both, all of them are odd.
Oh, that wasn't my intention, but thank you. Okay, so if we have the same sign, we don't have any chips canceling out. Okay, 5, 2, we combine them for 7. 2, 1, we combine them for -3. Okay, now let's look at example 2. Could you please model with your chips 4 negative chips and 9 positive chips?
Yeah, 9 plus 4. Attack! What?
I'm just laughing at your attack.
Because, you know, they have to attack to get down there.
Okay.
Attack each other. And then
They-
they subtract the population.
Yeah!
You know what? Whatever works for you. Okay. Do you have some positives and negatives canceling out?
Yeah, subtract that population.
Okay. So move them over, and you have how many left? 5 positive or 5 negative? We have 5 positive left. So we had 2, 3, 4. Me? It's possible. But it's none of your business. Okay. All right, what about 10 plus -3? If we have, you know what, I'm gonna back up. If I'm at 10 and I add -3 on the number line, I'm starting at 10 and I go backwards 3 for that -3. So we are at 7. Or you can think of it as I have 10 positive chips, 3 negative chips. The 3 of them cancel and we're left with 7. Okay, you guys go ahead and do C and D. I don't care if you use the chips or the number line or neither. I just want you to do it. And then check with your elbow partner. Okay.
No, boys. 1 and 2.
Oh, wait. Oh, yeah. I was thinking of 14, not.
Okay. Abraham, what'd you get for C? -3. 12 positive chips cancel out the negative chips, but we have 3 negative chips left over. Okay. Lily, what about D? 9. 3 negative chips cancel out some positives, but we have 9 positives left over. Tell me what's true about all the problems in example 2. Mason.
If they're the same signs, then you add them. If they're different, then you subtract them.
Okay. So up here, we had problems that had the same sign. So we grouped those chips together and we counted how many total there were. Whereas in example 2, do you notice how one's positive, one's negative, one's positive, one's negative, one's positive, one's negative. So we have chips canceling out and we're moving those off, okay? And now we are left with whatever chips remain. Okay, so 10 plus negative 3, a lot of you subtracted 10 and 3 to get 7, right? 12 plus negative 15, we subtracted 15 and 12 to get 3, but we knew that the negative would win out in the battle. Okay, so let's go ahead and look at, on the next page, example 3. Okay, whether you use the chips or not, you use the number line or not, I'm still gonna like kind of talk about the chips. 4 negative plus 6 negative. Are any chips canceling? No, we're totaling them together. So how many negative chips do we have? We have negative 10 chips. Okay. What about in B? Notice how we have 23 positive added to 5 negatives. Are we canceling? Yes. So we have 5 negatives that are canceling. Nope. I don't even know who said that, but no. Yeah. How many positives are going to be left? 18, because we're going to subtract those 5 away that canceled out with the 5 negatives. Okay, I'm going to give you a moment to do the other 4. Check your answers with your elbow partner, too. All right, Serena, what'd you get for C? 38. Okay. Evelyn, how about for D? Okay. Claire, E? Negative 43. All right, Abby, what about F? 11. Does anybody disagree with any of those?